you ready to learn about astronomy? Want to see the stars and the moon and the planets? Now, if we wanted to have a star party to educate children about the night sky, first we're going to need to find a telescope. One type of telescope we could use is a reflector, which we have here, which uses a mirror to converge the light at one point. The other two types of telescopes are refractors and catadioptrics. Catadioptrics use a series of lenses and mirrors to converge the light at one point where we can see the image of the object we're looking at. There are benefits and drawbacks to all of the types, but one of the most important qualities to look at is what the telescope will allow us to look at. For example, a reflector like this one is great for looking at deep sky objects, but not as good as a refractor is at looking at planetary objects. Children are more likely to be interested in viewing the planets than deep sky galaxies because they're familiar with them, which makes a refractor a great choice in this case. So here we have one of the main types of a telescope. This is a refractor. It's going to use a series of lenses to collect the light and focus it at one central point at the eyepiece, where you can then see the image of whatever objects you're observing. One of the important things to know about a refracting telescope, or any telescope for that matter, is its aperture, which is this. It's the light collecting area, and it's measured in the diameter across. The larger the aperture, the more light you can collect. Do you see why a refractor is going to be a better choice for us than this big old reflector? One of the other great things about using a refracting telescope is that they're easy to use and portable. We'll be looking at telescopes with an aperture between 3.5 and 6 inches, which will be great for viewing the stars and easy to transport. As for focal length, we'll want a telescope with a focal length that will allow us to transport it easily, and a smaller focal ratio which gives us brighter images. With all this information, we will need to consider some obvious attributes of the telescope as well, including cost and weight. Most likely, you don't want to spend over $2,000 for a telescope, nor do you want to lug around one that weighs more than you do. We selected 5 telescopes that fit our criteria. All 5 are refracting telescopes with an aperture between 90 mm and 152 mm. The first scope is the Celestron 6-inch f8 C6R GT Advanced Series Achromatic. It's great for viewing the moon and planets, just like we want to. Additionally, the scope boasts one of the highest useful magnifications of all the scopes at 300 times, and the lowest resolution of all our selections at 0.6 arcsecond. Also, the scope has a computerized go-to function unlike any of the others, which would allow us to spend more time teaching children about the night sky rather than positioning the scope. However, the scope is larger than all the others at 57 pounds and a focal length of 1,200 millimeters. The second scope is the Meade Series 6000 115 mm f7 ED Triplet Apo. It falls in between all our options in terms of aperture, focal length, and magnification. That being said, it still offers strong optics with 115 mm aperture and is also one of the lightest options at about 17 pounds, which would be great for transportation. However, it is also the most expensive scope at $1,999. The other telescopes have similar features with a more reasonable price tag. Our third possibility is the Celestron Astromaster 90 EQ refractor. At only $259, it seems too cheap to work well, but all our research asserted that Celestron telescopes are trustworthy and well made. It has the smallest aperture of all our choices, but at almost 90 millimeters, it's still enough for our purpose. Its fast focal speed of f/11.1 will make the images brighter than those from any other scope we're considering. However, the Celestron Astromaster has the worst resolution of all the scopes. Its resolution is 1.29 arcseconds compared to the second worst at 1.09 arcseconds. None of our main objectives are to study binary stars, though, so this shouldn't interfere with our goals. The next telescope we're considering is the Astronomy Technologies Astrotech AT106-106mm. At only 11 pounds, it's amazingly portable and the right type of scope for us. Only its price tag, $1,995, is a detriment. The final scope we would consider purchasing is the Celestron 6-inch f5 Omni XLT 150R. This is another great deal. Only $999 for the telescope and an equatorial mount. The scope also offers great optics from a trustworthy name. It's essentially tied with the Celestron 6-inch f8 C6R GT in terms of optics. Both are equal in aperture, highest useful magnification, and resolution. The Omni XLT 150R is slower in terms of ratio, but its smaller focal length and lower cost make it favorable nonetheless. So we can start by eliminating any telescopes that cost too much, as in over $1,000, because we're amateurs. We don't want to spend so much money on a telescope that isn't going to offer us that much more in terms of optics. And then we have to look further into the scopes themselves to make sure we're still getting a good deal. Although all of these are good scopes for viewing the night sky and educating children about the moons and planets, two can quickly be eliminated on the basis of weight. While buying the Celestron 6-inch C6R would provide superior observing experience, according to Astronomy magazine's report card based on size and type of scope, it weighs far too much to carry, yet alone transport to a part or other central locations where our starport parties could convene it. Even given the inclusion of a mount, it still isn't worthwhile. Its optics work perfectly for our objectives, but we don't need a computerized scope, nor would we be able to get much use of it at this weight. Similarly with the Celestron 6-inch Omni XLT, its detrimental weight overpowers all of the scope's positive attributes, for example, its reasonable price and fast focal speed. Given that the Celestron Astromaster only falls behind the other two in terms of weight and viewing nebulae and galaxies, it is a very good choice because our main interest isn't viewing galaxies and the scope still offers a fair view of them. It weighs only 23 pounds, which makes it transportable. The lower weight and slightly better optics of the other two aren't worth the extra money in this case, which makes the Celestron Astromaster our final choice for a telescope. Honey, I'm gonna go view the stars with my new Celestron Astromaster now!
Wait, honey, aren't you forgetting something?
Accessories! The first thing we will need is a telescope mount. The mount is important because it helps keep the telescope stable. The type of mount we will be using is an equatorial mount. This specific mount is designed so it is aligned with the Earth's axis, which makes viewing a single planet or star easier. A telescope's eyepiece allows us to view the night sky in different ways depending on its size. The eyepiece we will be using has a diameter of 2 inches. This size eyepiece gives the observer a wider field of view than standard eyepieces. Eyepiece filters can reduce glare, increase contrast, resolution, and definition. The filters we will be using are a Milne filter, color filters, and a light pollution reduction filter. For instance, when using a red filter, the filter will block out all other wavelengths except red wavelengths, making it easier to see red objects. Like if you wanted to see Mars, this would make it a lot easier. The last accessory we will need is a Barlow lens. This lens, when placed between the objective mirror and lens, and the telescope's eyepiece, doubles the magnification of the telescope. So now we have everything we need to view the night sky. Are you ready to go? Come on.